All right, so we're going to wrap up our last lesson of Unit 6 on similarity, and we'll be working in the coordinate plane. And the good news about this lesson is that there's really no new information to teach you. It's really about taking the accumulation of everything that you know and using that information to prove triangles similar using the same things that you've been using before. All right, so we're going to be in Lesson 8 for Unit 6 on page 52, and you can see that we're going to be addressing Standard 14.4. I can use my knowledge of similar figures to solve problems within the coordinate planes. All right, so now to get you thinking about those similar figures, all right, we have three sets of triangles here, three pairs of triangles. What I'd like you to do is see if those three triangles or three pairs of triangles are similar. So go ahead and pause the video, do the opener, flip it back on, and we'll see how you did. All right, so let's look at part A here. So hopefully you saw that you had vertical angles for sure. Now, once again, what we know is that the information is going to kind of guide us to which of those shortcuts for similarity we want to use. And so notice I only have two pairs of sides. So hopefully, and I'm going to throw this up here real quick. All right, you looked at the ratio, all right, of those sides. And if you look at that proportion, we do get 7 over 6 equals 7 over 6. So we know that the sides are proportional. So these are similar. And we can use side angle side for similarity. Now, the similarity statement, all right, I'm going to go down, let's start in this triangle. I'm going to go down the short side to the vertical angle, then up the long side. So that would be CAB is similar to triangle. And then so if I go down the short side to the vertical angle and then up the long side, that would be NAM. All right, so let's look at part B here. Now, in part B, notice we have all three sides in both triangles. So really the only shortcut that we're going to use, all right, we don't have any angle information, would be side, side, side. Now, once again, if I look at that ratio, all right, for all three pairs of corresponding sides, right, I can see that the proportion is equal, right? I get to 13 over 2. Now, you may have done this as a decimal, and that's totally fine. So it doesn't matter if you look at this in a fraction form or decimal form. The key piece is that everything has to be equal. So, all right, that's the big idea with the proportion. All right, so these, once again, are similar. And this would be side, side, side for similarity. And now, once again, when we look at that triangle, all right, similarity statement, all right, I use the sides to guide me. So notice here, I'm going to go up the short side and then down the medium side. So NLM is similar. And then once again, I'm going to go down the short side, or up the short side and down the medium side. So QSR, nope, triangle, let me get that in there, QSR. Now, once again, all right, this isn't the only way you can write that similarity statement. But whatever you write, N and Q should be in the same position, L and S should be in the same position, and M and R should be in the same position. All right, now let's look at part C. Now, once again, notice we have no side information. So the only possible shortcut we can use is angle, angle. All right, and once again, we get a pair of vertical angles here and here. We have two right angles, and we know that all right angles are congruent. So we do, in fact, know that these triangles are going to be similar. And it is by angle, angle. And then once again, I'm going to look at my triangle similarity statement. I'm going to go right angle, vertical angle, and then the other angle. So that would be UTV is similar to triangle. And then I'm going to go right angle, vertical angle, the other angle, ETF. All right, so now, those are our three shortcuts, right? Now, what we're going to do is use these same shortcuts, but in the coordinate plane. So the only thing that changes now, all right, is how do I get that information in the coordinate plane? So let's review some information. So you must use the, all right, Pythagorean theorem, right, to find side lengths, right? So it's always a squared plus b squared equals c squared, right? Okay, so if we want to use, right, so notice we won't have the lengths in the coordinate plane. We would have to find these numbers, and we would use the Pythagorean theorem to do that. Now, to find angles, right, one of the ways we can do that is to show that two lines are parallel. So we must find each line's slope, and we must show that those slopes are equal. And the reason we want parallel lines is we know from our prior work, right, that we get three types of angles that are going to be congruent, right? So we know corresponding angles are going to be congruent. All right, we know alternate interior angles are congruent, all right, and we know alternate exterior angles are congruent as well, right? Now, the difference is in the coordinate plane, right, we have to show that the lines are parallel first, and then we can go to these relationships. All right, let's flip to page 53, all right? Okay, we had right angles in part C. Well, the way we get right angles in the coordinate plane is we have to show that the lines are perpendicular first. So we have to show that each line's slope are opposite and reciprocal. All right, so for example, if I had one slope that was 2/3, right, I would want my second slope to be -3/2, so opposite and reciprocal. All right, and once we have that and the lines are parallel, or excuse me, perpendicular, we know that we have right angles. All right, and we know that all right angles are equal, right? And so notice we're going to get to the same information, but there's a lot more work involved to get that information. All right, so just like before, I can identify vertical angles in my diagram, then I know that they are congruent. Okay, so if you see vertical angles, right, in a picture in the coordinate plane, we can say that they're equal and congruent, just like we did here, right? So if we see this in the coordinate plane, it works just the same way. All right, so a little bit of review on some of the coordinate plane stuff. So now I'm going to go through two examples with you. All right, so let's look at problem 1 here. All right, so notice with problem 1, all right, it's a figure that's very similar, right? It looks very similar to what we have here, right? Okay, so notice right away on problem 1 here, all right, I can see that I have vertical angles. So I know, right, and I'm just going to put angle 1 and angle 2 here, right? So I know angle 1 is congruent to angle 2, right, because they're vertical angles. Which means if I want to use angle, right, I just have to find one more pair of congruent angles. Well, when I look at this picture, to me, it looks like WI, okay, and OB here, all right, okay, are parallel. And if I can show that they're parallel, then I can go for some of those types of angles that we listed on the previous page. So let's find the slopes here. So I'm going to look at the slope of WI here. And so when I look at my slope, I go up 1 and I go to the right 1, 2, 3, 4, 5, 6. So my slope is 1/6. And then I'm going to look at OB here, and I want to look at its slope. And notice here I go up 2, and then I go over 12. Now, once again, when we're comparing slopes, whether it's for parallel or perpendicular lines, we want those slopes in lowest terms so we can compare them. So always be sure to, all right, reduce those slopes. Notice both of these line segments have the same slope. So what that means is WI is parallel to OB. All right, they have equal slopes. Now, what that means is now we can go back and we can try to find any of these three types of angles and say that they are congruent. All right, so when I look at my picture here, all right, I'm going to label this as angle 3, and I'm going to label this as angle 4. And so notice angle 3 and angle 4 are alternate interior angles, all right, for WI and OB. All right, so this angle is congruent to this angle. So angle 3 is congruent to angle 4, and that's because they're alternate interior angles, right? Now, you could have easily have come up and said these two angles were congruent because they are also alternate interior angles, right? But we only need, all right, two pairs. Okay, and so now what we know is we know our triangles, and once again, I'm going to go alternate interior angle, vertical angle, other angle. So that would be, you know, actually I have this statement here, so I'm just going to copy that statement. All right, and that would be by our angle, all right, shortcut. All right, so there you go. All right, so you can see that we're really doing the same thing that we did in part C here. But notice we had to do a little bit more work, right, to get those other sets of angles. And that's really the challenge with coordinate geometry, is you have to do the work to find those relationships, okay? All right, so now let's go ahead and go to page 54 here. And I'm going to look at where you have to use, all right, the Pythagorean theorem to find some side links here. So notice now the difference here. These triangles aren't touching, right? We don't look like we have parallel lines. We definitely don't have a transversal to connect those parallel lines. We won't be able to get the alternate interior angles and those kind of things. We don't have vertical angles, right? So it looks like I'm, you know, I don't really, and these lines don't, to me, don't look perpendicular. That doesn't look like a right angle. It looks a little bit obtuse to me. So it looks like, all right, we're going to have to use side links and side, all right, to prove that these triangles are similar. Now, technically, you can use side every time. All right, you can find all three side links in one triangle, find all three side links in the other triangle, set up your proportion every time. But that's a lot more work most of the time. Now, sometimes you have to do that work, which is what we're going to do here. So now, what I'm going to do now is I'm going to find the lengths of all my sides here. All right, I'm going to start with BI here. And so what I know is I'm going to always draw in my right triangle here. when I find my side lengths, right? And so what I know is bi squared equals 2, and then I gotta find my two side lengths here. So 1, 2, 3, 4, 5, 6 squared plus, and then I can find the height here, 1, 2, 3, 4, 5, 6, 7, 8, 9, plus 9 squared, right? Okay, and then if I look at my calculator, let's do that real quick. All right, so 6 squared plus 9 squared is 117. And now I'm going to take the square root like that. All right, so bi is the square root of 117. Now, I'm not going to try to reduce our radical here. All right, I'm going to leave it as it is, and I'll show you why in just a moment. Okay, so now, all right, I'm going to try and find ig here. So ig squared equals, and then once again, I'm just going to draw in my right triangle real quick. All right, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9 squared. Plus, and then 1, 2, 3 squared. All right, so 81 plus 20, or excuse me, 81 plus 9 is 90. All right, so ig squared equals to 90. And that means that ig is equal to the square root of 90. And then we have one more side here, so we have to find bg. All right, so bg squared equals 2, and then once again, I'm just going to, and you don't actually have to draw it in, you could just count it if you want, but I'm very visual, and it helps me. All right, so when I look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 squared, plus, and then 1, 2, 3, 4, 5, 6 squared. All right, so bg squared equals 2, and let's see, 15 squared plus 6 squared. Let's see what we get here, if I can hit the right key on my calculator here. All right, so let me try that again here. 15 squared plus 6 squared. That is 261, so bg is equal to the square root of 261. All right, so there's my three side lengths. Now, the reason why I didn't reduce anything, because within the square root, right, I can see my side lengths, and that's going to help me put them in order. So I know right now, like, square root of 90 is my smallest side, square root of 117 is my middle side, and the square root of 261 is my longest side. So seeing those numbers inside the radical makes it easy to kind of put them in order here. And remember, we're just looking at that relationship, so we don't really need them reduced to do so. All right, so now let's find our three side lengths in our smaller triangle here. All right, so I'm going to start with EL right here. Okay, so EL squared equals 2, and this is a small triangle here, and so it's 1 squared plus 1, 2, 3 squared. All right, so EL squared is equal to 10, so EL is equal to the square root of 10. I'm sorry if you couldn't see that. All right, and then let's find ED here. So ED squared is equal to, draw that in real quick, and it looks like 2 and then 1, 2, 3. So 2 squared plus 3 squared. So ED squared is equal to, that's 13. And that means that ED is equal to the square root of 13. And then our final side here is LD here. So LD squared is equal to, and then draw that in real quick here. All right, so that's 2, and then 1, 2, 3, 4, 5. So 2 squared plus 5 squared. So LD squared is equal to 29, which means that LD is equal to the square root of 29. So there are three side lengths for that triangle. So now, once again, we got to put those in order here. So I get the square root of 10, square root of 13, and the square root of 29. And then once again, remember, we just want this proportion to be equal. So I'm going to just go to my calculator. All right, square root of 90. Oops, I guess I got to get 90 in there. And then you make sure you get outside the radical, and then square root of 10. And that looks like it's 3. How about that? All right, and then square root of 117 divided by square root of 13. And that's also 3. And so one more here, second square root of 261. All right, divided by square root of 29. And that is also 3. All right, so wonderful there. So now we can see that all three, all right, corresponding sides are proportional. All right, so notice it's the same, whoops, wrong page here. If I go back, right? So that's exactly what we did here, right? Okay, but notice we had to do the work to find all the side lengths. All right, so same process, just more work to get there. So we do know that our triangles are similar, right? So triangle BIG is similar to triangle DEL, and that's by side, side, side. All right, so there's an example of how we work in the coordinate plane. All right, so finish up your work, and that's the end of our unit, and I'll see you in the next one.